So today we are going to talk about all of the details for our unit on 5.5a, classifying 2D figures in a hierarchy of sets and subsets. And we've got to start by knowing what a 2D figure is. So we just need kids to know that 2D means 2 dimensions, and those 2 dimensions are length and width. This kind of lays the groundwork for before we get to our volume unit, when we will add the third dimension of height. So we start by knowing we're working with 2D figures. And then in 2D figures, we're talking a lot about polygons. We have to know what a polygon is. It is a classification of 2D figures, and they are closed figures with all straight sides. So this would be a good Freyer model activity. They can put a definition, they can give you an example, and they can give you a non-example, and then some pictures of polygons. So it's a closed figure with all straight sides. Okay, so that means it could be triangles, we could be talking about quadrilaterals, we could be talking about any number of sides as long as they're all straight and it's closed. So a straight-sided figure with 3 sides that looks like a triangle but a part of a side is missing so that it's not a closed figure would be a non-example of a polygon. A figure that's closed but has curved sides like a circle is not a polygon. A semicircle has one straight side, but the other side is curved like a half circle. That is not a polygon because it's a closed figure, but it doesn't have all straight sides. So both of these attributes have to be true for it to be a polygon. So within those 2 big overarching topics, we are going to talk about quadrilaterals and triangles, and there are some key things about both of those that we have to watch for with kiddos. So let's start with some key terms for quadrilaterals. One being a parallelogram. Kids think from younger grades that any shape that looks like this, that's a terrible drawing, but you know what I mean. That's a 4-sided figure that looks like that is a parallelogram. The problem with that is there are a lot of figures that are a parallelogram. A parallelogram is not the name of a specific shape, it's the name of a classification of shapes. So we can talk about what are the attributes of a parallelogram. Well, it's a quadrilateral. That means it has all 4 sides. It's a polygon with 4 sides. We know that opposite sides are congruent or equal in length. We know that opposite angles are congruent. So opposite sides congruent. This side is equal to this side, equilateral. This side is equal to this side, equilateral. Opposite angles are congruent. This angle is equal to this angle, or equiangular. This angle is equal to this angle, equiangular. Then we also know that opposite sides are parallel. So if I look at that, this side is parallel to this side. Now, not in my drawing, but in a parallelogram. And this side is parallel to this side. So if we know that all of those things are true for it to be considered the classification of a parallelogram, then we have to consider what other shapes could fall into that classification. So we could say, is a square a parallelogram? And we could say for a square, is it a quadrilateral? Yes. Are opposite sides congruent? Yes, all sides are congruent, so opposite sides are congruent. Are opposite angles congruent? Yes, all angles are 90 degrees. They're all right angles, so they're all congruent. and are opposite sides parallel? Yes, so a square is a parallelogram. Then we're going to think through the same process for a rectangle. Is a rectangle a quadrilateral? Yes, it is. Are the opposite sides congruent? Yes, the opposite sides in a rectangle are equal. Are opposite angles congruent? Yes, all angles are right angles. They're all 90 degrees, so they're all congruent. And are opposite sides parallel? Yes, so a rectangle fits all of the requirements of being a parallelogram or being in the category of a parallelogram. Let's think about a rhombus. Does it meet the criteria? It is a quadrilateral. Opposite sides are congruent. Yes, in a rhombus, all sides are congruent, so that is true. Opposite angles congruent. Yes, the opposite angles are congruent. Opposite sides parallel. Yes, opposite sides are parallel. That is true, so a rhombus is a parallelogram. And last, let's think about a trapezoid, because a trapezoid has some unique characteristics that no one else has. Trapezoid. So, with its unique characteristics, is it a parallelogram? Is it a quadrilateral? Yes. Are opposite sides congruent? No, they don't have to be. Are opposite angles congruent? No, they don't have to be. Are opposite sides parallel? No, only one side is one set of sides is parallel. So a trapezoid is not a parallelogram. It has only one set of parallel sides. So if I think about a trapezoid, kids think of I'm going to have to move my paper up. This shape. My paper is sticky at the top. It doesn't want to move up. They think of this shape, and that is a trapezoid. But it doesn't matter the orientation of this shape, so meaning it could be like this and still be a trapezoid, because one set of sides is parallel. Only one set, not both sets, only one. But kids also need to know that there is a right trapezoid. These two sides are parallel, these are not. It's still a trapezoid because it has exactly one set of parallel sides. This is just called a right trapezoid. Okay? Now let's think through that phrase that causes a lot of confusion and frustration for our kids. A square is a rectangle, but a rectangle is not a square. A square is a rhombus, but a rhombus is not a square. So square is a rectangle, but a rectangle is not a square. Let's prove it. What are the attributes of a rectangle? We know it's a quadrilateral. Opposite sides are equal or congruent. All angles are congruent. Opposite sides parallel. Now, is that true of a square? So let's think about a square. Is that true? Is it a quadrilateral? Yes. Are the opposite sides equal or congruent? Yes, all sides are. Are all angles equal? Yes, all angles are equal. Are opposite sides parallel? Yes, so a square is a rectangle. But now let's see why a rectangle is not a square. So square, we know is a quadrilateral. All sides are congruent. All angles are congruent, and opposite sides are parallel. So is that true of a rectangle? So let's see if that's true of a rectangle. Is a rectangle a quadrilateral? Yes. Are all sides equal? No. Opposite sides are equal, but not all sides. I'm going to move my camera a little bit. Are all angles equal? Yes. They're all 90-degree right angles. Are opposite sides parallel? Yes. But we cannot say that a rectangle is a square because it doesn't fit all of the attributes of a square. Because all sides are not equal, a rectangle is not a square. So that's why that is true. The same is true for a rhombus and a square. So let's look at that. Same thing we're going to do here. So we're going to say a I'm going to write it the other way so it matches the one I did before. A square is a rhombus, but a rhombus, I'm going to abbreviate because I'm going to run out of room, is not a square. Let's prove it. What are the attributes of a rhombus? It is a quadrilateral. All sides are equal or congruent. Opposite angles are congruent. Opposite sides parallel. Oh, I'm not even on the paper anymore. Let's slide this down. Let's see if that's true of a square. Is a square a quadrilateral? Yes. Are all sides equal? Yes. Are opposite angles equal? Yes. Are opposite sides parallel? Yes. So a square meets the requirements of being in the category rhombus. Now, let's do the same thing we did for rectangle and do that for square and rhombus. So for a square, we know it's a quadrilateral. We know all sides are equal. We know all angles are equal. And we know opposite sides are parallel. So is that true of a rhombus? We know that a rhombus is a quadrilateral. We know that all sides are equal. Are all angles equal? No. Opposite angles are equal. Are opposite sides parallel? Yes. But because all angles are not equal, a rhombus is not a square. So far, so good? Let's talk about, quickly, a isosceles triangle and an equilateral triangle. I'm going to adjust for a second so we have some more room. And let's talk about isosceles and equilateral. Isosceles triangles means that was going to be an arrow, at least two equal sides or two congruent sides. When it says at least two, it could be more than two. What do we know of an equilateral? An equilateral triangle, all sides are equal in length. So they are all congruent. That's why it's called equilateral. Well, if all sides are equal, are at least two sides equal? Yes. So then that means that an equilateral triangle is also an isosceles triangle. That got us a couple of years ago on STAR, so we have to make sure kids understand isosceles is at least two equal sides, not only two equal sides. There's a big difference there. Okay, one last thing to look at, hierarchies of sets and subsets. I'm going to slide this over so I'll have some blank room to write. That means that I'm categorizing these from their broadest description to their most specific description. So if I think about the hierarchy of a square, the broadest description I could give of that is a 2D figure. You can't see what I'm writing. 2D figure. The next, a little more specific of a 2D figure is that it's a polygon, meaning it's a 2D figure with all sides are closed and all sides are straight. The next, a little more specific, would be a quadrilateral, meaning it has 4 sides that are all straight and closed. Then I could say a square is a parallelogram, because remember, we proved right over here the shapes that would be called a parallelogram. So a square is a parallelogram. Here is where we have to split this out a little bit. We would agree that a rectangle is a little more specific way of naming a square, because we proved that a square is a rectangle. But we also know that a square is a rhombus, and both of those are parallelograms, so they have to live both under parallelogram. And from here, we would say we are to the specific name of a figure. There's nothing else that could be classified as a square. It is the name of a shape. All of the rest of these are classifications of shapes. Now, if I want to think about one more specific thing on this hierarchy for quadrilaterals, I would have to put a trapezoid. But remember, it has to live out here. It is a quadrilateral, but it can't go under parallelogram, because remember, we proved it's not a parallelogram. And last, if I wanted to figure out, well, what about these triangles? Well, triangles can live on this hierarchy too, because they are 2D figures. They are polygons, but they're not quadrilaterals. So I would need, I'm going to have to figure out where I can write really small. Here would be triangles. And I could have an isosceles triangle, and I'm going to abbreviate, or I could have a scalene. And then I have to know that my equilateral triangle has to live under isosceles, because an equilateral is an isosceles. It fits those attributes of an isosceles triangle. So if I think about a circle, it can't live under polygon, because a circle is not a closed figure with all straight sides, but it does have a length and a width. So it's a 2D figure, it's just not a polygon. And there's several that we could put out here. We could put semicircle or half circle. We could draw some non-examples. Under polygon, we could put pentagons. We could put hexagons. So there are lots of other things we could add to this. These are the main things we need students to know. Please let me know if you have any questions.